My name is G Shiva and my roll number is H5. Today my topic is recently development in stored grain sensor monitoring and management technology. Sensoring for monitoring and controlling stored grains. Grain temperature monitoring. Since grain is poor heat conductor, many temperature sensors are required in silo to ensure timely detection of any slow developing localized hotspot to prevent spoilage in the inductor of an early stage of grain spoilage and correct corrective action can be taken by switching on erosion fans at appropriate times to cool the grain. Grain moisture monitoring. The ultimate standard for a grain moisturing content measurement is oven dry method, where the grain is placed in oven and dried at to 103 degrees Celsius until the mass does not change with time. While the process is accurate and repeatable, it requires about 24 hours until the cereal grain moisture content is known. This can be sped up using micro drying of the sample, but it still cannot give real time moisture content measurement. There are several methods to achieve real time measurement of grain moisture. This first is subsampling and offline measurement VAI capacitance near infrared or microwave technologies. The second method in inferences of moisture content by measuring the relative humidity and temperature of the interrangular air in the stored grain and relating the data to grain equilibrium moisture content. Offline moisture measurement can be achieved by taking sample of grain from silo via the top, bottom or other sampling door. The sample is then analyzed using a variety of moisture content sensor types that are made by a range of manufacturing. Collecting the sample can be time consuming dangerous due to working at height and breaks any airtight seal that the silo may have had. There are many types of offline grain moisture meters. Capacitive sensors are widely used in many agriculture applications for moisture measurement. The underlying principle of capacitive sensor is based on change in capacitance in response to moisture content changes. Capac- Capacitive moisture sensors are collaborated for the desired grain type and moisture range to directly moisture the moisture content based on the primitive and temperature of the specific grain type. The grain is placed between two parallel plates for moisture measurements. Nelson et al. Present in a detailed review of using cereal grain primitive for measuring grain moisture. Most of the commercial bench top grain moisture meters, including the unfired grain moisture algorithm based official grain moisture meter in United States, use this capacitive sensing technology. As an extension of the technology, McClintosh and Cascada developed a fingering field capacitance sensor based grain probe for measuring moisture content of in-suit bulk grain samples, but their use in silos is not common. NIR moisture meters are gaining popularity as they can also calibrated to simultaneously measure other parameters such as grain proteins. CO2 carbon dioxide monitoring. Recent research studies have shown that increased carbon dioxide levels indicate there is a mold spoilage or insect activity or both inside the stored grain. A non dispersive infrared detector can be used to measure the transmitted light through an air sample to measure the transmitted light through an air sample to measure carbon dioxide concentration of the air in the silo headspace. The NDIR works on the principle that molecule absorbs infrared radiation at specific wavelength. So when infrared radiation is passed through carbon dioxide in an air sample, portion of it will be absorbed and the remainder will be transmitted. As per the Lambert-Beer law, the amount of infrared radiation absorbed is proportional to the concentration of carbon dioxide. Only for grain storage facilities with downward flow aeration fan should a carbon dioxide sensor be placed in exhaust airstream rather than being placed in headspace. Fumigation monitoring. POSPAN is currently the most common fumigant used to control insect infestation in grain. However, insects are developing resistance to POSPAN due to non-uniform and low dose application of POSPAN. To achieve 100% mortality, it is important to apply a lethal concentration uniformly throughout the grain bulk for the required exposure time. Unless the silo is airtight, the POSPAN leaks out and lethal concentration cannot be maintained. POSPAN concentration monitoring sensors are now commercially available and have been used in field testing of sealed silos to compare mortality rate with POSPAN fumigation is in non-sealed silos. An NDIR sensor is used for POSPAN concentration measurement, and it can also be used for the pest control fumigants such as a methyl boramide, sulfur fluoride. Web-based real-time fumigation monitoring can be used with the technology to ensure maximum effect and help minimize insects and resistance to fumigation in stored grain. Headspace condensation monitoring and control. Appreciate use of a fan control strategy, feedback from moisture and temperature cables, whether the station headspace sensors and sufficient airflow rates results in optimized drying and aeration fans control performance. Simulation studies have also shown that automated fan and heater control give better result in terms to uniform and timely drying to target moisture and energy consumption compared to manual fan control. Headspace temperature can rise up to 15 to 20 degrees above the ambient level during sunny and or a hot day. This encourages evaporation of water from the grain and thus increase the humidity of the air in headspace at the night as the outside. Insector electronic insect detector with dual beam infrared sensor head section. Insecting damaging multiple and frequent sampling by manual inserting and a probe taking a sample from the ground silo is both time consuming and labor intensive for detecting low insect density large samples. As an alternative to grain sampling probes, pitfilly type in select traps are also used to estimate insect density. They are cylindrical tubes with small holes that are inserted into grain below the top surface, and insect crawl and drop through the holes into the cylindrical trap and are collected to the bottom of the trap. This method is very labor intensive process which requires physically entering the silo to insert and collect the traps on a regular basis, pulse the manifold identification and counting insect. Thank you. The main thing is here recent development in store grain sensors monitoring and management technologies are grain temperature monitoring, grain moisture monitoring, carbon dioxide monitoring, fumigation monitoring, POSPAN pH3, headspace condition monitoring and control. Here we can observe the structure. of headspace condition monitoring and controlling.